Welcome students. Let us see a very interesting question from the chapter sets. So let us see. Here question is, in each of the following determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Means in case of false statement, we have to explain with the help of an example. Okay. So first, here if X belongs to set A and set A belongs to set B, then X belongs to set B. Let us see here. First, we'll prove it with the help of an example that this statement is false. Okay, how? Suppose set A is having one element 1, 2 and set B is having this set consisting of element 1 and 2. So this condition is here and we have to show that X belongs to B is false. So here we see that here this element 1 belongs to set A, this element 1 belongs to set A, and set A itself belongs to set B. Set A is a set having element 1 which is belonging here. So you can say here this 1 belonging to set B, that is element A belonging to set B. But is it right, X belonging to B? X is here 1. X is 1. But 1 is not belonging to B here, but this element 1 is not belonging to B. So X belongs to B, this statement is false, because here we are taking X is 1, 1 is belonging to A, set A is having element 1 which is belonging to set B. These two propositions are being fulfilled, but this statement X belonging to B is false. Okay, that's why this statement is false. Now let us see question number 2. Here if A is a subset of B and B belongs to C, then A belonging to C, then A belonging to C. This statement is false. We'll prove it with the help of an example as being asked here. Give an example. So A is a subset of B and B belonging to C. Suppose A is having element 1 and B is having element 2, 3. So clearly A is a subset of B. This set A having element, this is 1 and 2, okay? 1 and 2. So A is a subset of set B, correct? And here we will take set C with elements such that A belonging to C, okay? So A belonging to C. So C consisting of element 1 and 3. A is a subset of B. This is A, this is B. So A is subset of B. And B belonging to set C. Set C will be like this. 1, 2 and 3. So A is a subset of B. Elements of set A are also available in set B. So A is a subset of B. This is correct. B belonging to C. Set B is a set having elements 1, 2, which is belonging to set C. This is also correct. Then A belonging to set C. A means set 1 belonging to C. This is not correct. Here we find A is not belonging to set C. That's why this statement is false. Once again you see, A is a subset of B. You see, A is a set having element 1 and B is a set having elements 1, 2. So definitely each and every element of set A is available in set B. So set A is a subset of set B, correct? B belongs to set C. This set B is belonging to set C because this B is a set having elements 1, 2, which is in set C also. So B belonging to set C. This is correct. This proposition is correct. And then whether A belongs to C or not. But what we find here, A singleton set having element 1 is not belonging to this set C. So this is false. And third, here if A is a subset of B and B is a subset of C, then A is a subset of C. This statement is true. Let us see how. Let X is any element of set A, okay, and A is a subset of B, and A is a subset of B. What does it mean? If A is subset of B, means each and every element of set A must be in set B. All elements of set A must in set B, okay. So this X is belonging to set B also. Therefore this X is belonging to set B also. And B is a subset of set C and B is a subset of set C. So B is a subset of set C means each and every element of set B is also available in set C. And here we see that X is belonging to B. So X must be in C also. X must be in C also. So what we are finding? Here we have started with X belongs to A implies that X belonging to C. Means all elements of set A are also elements of set C. What does it mean? It means set A is a subset of set C. So this is true. Now fourth, if A is not a subset of B and B is not a subset of C, then A is not a subset of C. This statement is false. We'll explain with the help of an example. A is not a subset of B. So let us take set A having element 1, 2. And we'll take set B having element 2, 3. So clearly A is not a subset of B because 1 and 2 must be in set B if A is subset of set B. So here 1 is not in set B, that's why A is not a subset of set B. This statement. And B is not a subset of C. B is having element 2, 3 and suppose C having element 1, 2 and 5. 1, 2 and 5. B is having elements 2, 3 and C is having elements 1, 2, 5. So this element 3, this member 3 of set B is not in set C. So therefore B is not a subset of set C. But what we find here, A is having elements 1, 2 and C is having elements 1, 2, 5. So each and every element of set A is available in set C. So A is a subset of set C. A is a subset of set C. Here given conclusion, A is not subset C. But what we are finding, A is a subset of C. So this statement is false. Now next, fifth. If X belongs to A and A is not a subset of B, then X belongs to B. Correct? So this statement is also false. Let us take example. Suppose set A is having element 1. So X is 1 here, X belonging to A. And A is not subset of B. And B is a set having elements 2, 3. So therefore we find here that A is not a subset of B, because A is having element 1 but B is not having this element 1. So definitely A is not a subset of set B. So this is the proposition given in this question here. X belonging to A, we are taking X is equal to 1 here, this is belonging to A, and A is not subset of B. Definitely A is not subset of B. Then we have to check that X belonging to B. X belonging to B. You see, here X is 1, which is not belonging to B. Also, here 1 is not belonging to set B. X is 1, which is not belonging to B. But what is the statement? X belonging to B. That's why this is false. And last question, last part of this question. If A is a subset of B and X does not belong to set B, then X does not belong to set A. This statement is true. Let us prove it. On the contrary means contradictory. On the contrary, let X belongs to set A. Of course, statement is here X does not belong to A. On the contrary, we are supposing X belongs to set A. And A is a subset of B. So X must be belong to B. And also A is a subset of B. So this implies X belonging to A and A is subset of B. It means when A is subset of B, when all the elements of A are available in B. So if X is in A and A is subset of B, then definitely X belonging to B. So you see, if we suppose X belongs to A, then we are getting the result X belong to B. But here given that X does not belong to B, so we cannot suppose that X belongs to A. It means X does not belong to A. Therefore, this contradiction shows that X does not belong to A. Because if X is belonging to A, then this statement is becoming false. This proposition is becoming false. But we have to suppose that this is given, cannot be false. So if it is true, then X does not belong to A is true. If X belong to A, then it becoming false, which cannot be, isn't it? So X does not belong to set A. So the contrary, X belongs to A, X belongs to B. So it implies that X does not belong to A, because here proposition is that X does not belong to B. So when we are supposing that X is belonging to A, we are getting the result X is belonging to B. So if X is not belonging to B, we cannot suppose that X is belonging to A. So X must not belong to set A. So this statement is true. So these are little bit confusing, but after doing a little practice, we will have a command over this type of questions. So you should do these questions carefully. We can solve it very easily. So thank you very much for watching this video.